Hi, welcome to Animation for Anyone. My name's Alex. In today's lesson, we're going to help answer the question that every animator asks themselves hundreds of times a day. How much space should I put between these frames? The answer will depend on two things: how fast you want your object to move, and whether it's speeding up, slowing down, or staying constant. The first part of this is pretty easy to answer. If you want your object to move quickly, make the spacing further apart, and if you want it to move slowly, make the spacing closer together. The second part of the question, speeding up, slowing down, or staying constant, takes a little bit more thought. It means that we need to look at the spacing of several frames to make sure we're creating the motion that we want. So to really quickly answer that question, if you want to make your animation speed up, look at the last two frames and make your next frame further apart than them. If you want to make your animation slow down, make your next frame closer together than those last two frames. And if you want to keep your speed constant, make your spacing the exact same as those previous two frames. That might be the only information you're looking for right now. But personally, I like to understand why things happen in animation. So for the rest of this class, I'm going to dig into those three options and try to understand them better. And just a little warning, I like to think of some of this stuff from a slightly scientific perspective. Don't worry though, this is animation science, not like real science class science. And just to reassure you, here's a little example of just how simple I want to keep it. Imagine I have a coin on a table, and I move my finger towards it. When I touch the coin, it starts moving. We certainly wouldn't expect the coin to start moving before I touch it. So to make it move, I added force. This is the key to the next few minutes. Some forces aren't things we can see easily, things like friction or gravity. But if it helps, you can think of them just like the finger in this example. They push against an object in a particular direction. Okay, let's get back to those three options. When we first start animating, it's tempting to make everything move at a constant speed. In fact, many animation programs use a constant speed as their default, and it's easy to understand why we do it. We know how many frames we want the animation to take, so we divide the distance we want to travel equally by the number of frames and animate away. It's good to understand why an object might move at a constant speed, and then decide if it's right for your motion. Let's look at something moving at a constant speed. This cyclist is pedaling to move forward, and the wind and the friction from the road is pushing back against him. Because the cyclist is moving at a constant speed, we can tell that the force from the pedaling and the force from the friction are perfectly balanced. This is an idea we're taking from science. For something to be moving at a constant speed, or even just to be sitting still, all of the forces at play need to be perfectly balanced out. This careful balancing act between all of the forces is one of the reasons we don't see constant movement as often in the real world. And if we do see it, it's usually accompanied by the movement speeding up and then slowing down. So that brings us neatly onto the idea of speeding up and slowing down. Let's look at how they work. This ball was moving and then it stopped. That's because it's got friction acting on it, but no other forces pushing it forward. So the balance is thrown out and we slow down. This car, on the other hand, is stopped and then it starts speeding up. It's able to do this because it's got a whole engine to create force that overcomes the friction. So once again, the forces are thrown out of balance and we speed up. As you probably remember, spacing that gets closer and closer together like this is called deceleration and shows an object slowing down. And spacing that gets further and further apart is called acceleration and shows an object speeding up. Animators sometimes call acceleration and deceleration easing. So the important takeaway with acceleration and deceleration is they require some sort of force to be happening, and that force needs to be greater than any of the other forces at play. Okay, so that's the sciencey stuff. Let's look at a couple of examples and try to tie those ideas into our animation. We have a large, heavy ball. This ball is still, so it wants to stay still. And it's going to stay still until we apply some force to it. So let's do that. Now, let's break down the spacing a little. Our character applies force to the ball, and it accelerates forward. For a brief moment, the character's force and the friction force are equal, and we move at a constant speed. And then the character gives up and loses contact with the ball, meaning that the only force acting on the ball is friction, so it slows down. At this point, you might be thinking, okay, I get it. We just need to add some speeding up and slowing down at the end of each movement, and we'll be fine. That'll kind of be true a lot of the time, but there are loads of examples where it won't be true, and we need to think about those too. In this example, I want to have a ball that bounces across the screen. If we use the spacing I just talked about, it looks a little something like this. It looks interesting, but I don't think it looks much like a bounce. If I think about the main force affecting the ball, gravity, I can decide the ball will speed up as it moves with gravity and then slows down as it moves against gravity. That feels much more like a bounce to me. The good thing is now that I've figured out which bits are speeding up and slowing down, I can exaggerate those things as much as I want, and it will still generally work. You can use the same thought process for characters too. There are two main reasons you might want to exaggerate your spacing: to add impact and appeal to your movement, or to help communicate to the audience. Usually by giving us a few extra frames and a little less movement to focus on the most important poses. As a general guide to exaggerating spacing, break the laws of physics as much as you like, but break them in a believable direction. I use forces to help me find that direction. Sometimes you don't want to worry about friction or gravity or forces at all. You just want to make things move around the screen. And that's totally fine. It's animation. We can do whatever we want. Speeding up, slowing down, and staying constant are still the only options you need to choose from though. And it's worth remembering our brains have evolved to interpret movements to mean certain things, so understanding the physics behind the scenes can still really help. As an example, one of the biggest issues that beginners battle against is their animation feeling shaky. This is where the spacing between the frames changes randomly every frame. Thinking about the lessons we've just learned, it would mean that there were different forces acting on the object 24 times every second. This sort of thing is pretty rare in the real world, so often it feels like something's out of place. There's nothing wrong with making shaky animation, but it's useful to understand why your motion feels the way it does. Okay, so I admit this is a pretty long-winded way to answer that original question: how much space should I put between these frames? So let's simplify things a little. While you're animating, have a quick look at the spacing of the previous frames, and then decide if you want to be speeding up, slowing down, or staying constant. If you want to be speeding up, make the spacing further apart than the previous two frames. Slowing down, make it closer, and if you want to stay constant, make it exactly the same. I actually tend to look at 3 or 4 frames before my current frame, which helps keep things a bit smoother. If you're having trouble choosing between the 3 spacing options, it might be worth thinking about the forces at play to help narrow things down. Pay special attention to contact poses, because this is where the forces often change most dramatically. And don't be afraid to exaggerate the spacing if you think it's going to help your animation. Spacing is one of the most important aspects to animation, and because we don't experience it in real life very often, we have to be kind of organized in the way that we think about it. So hopefully this class has given you some ideas about how to approach spacing in the future. Now for a little bit of homework. Create 3 animations between 1 and 3 seconds long. In your first, show something speeding up. In your second, something slowing down. And in your third, something staying constant. I hope you've enjoyed this class. Please don't forget to check out the other videos in this series, and I'll catch you next time.